Hi, good day everyone. This is Miriam again, and today we are moving on to the backbone of the system performance, which is the random access memory. So, specifically for today, we are going to discuss the differences between the DDR memory. So from DDR, DDR2, DDR3, and DDR4. So the fundamental story here is a constant improvement. Each generation delivers greater performance and better energy efficiency. Now, let me introduce to you to the DRAM generations. So this is the evolution of the RAM from DDR to DDR4. To give you a quick background, RAM, or what we call the random access memory technology, specifically the DDR SDRAM, which stands for double data rate synchronous dynamic RAM, evolves every few years to increase performance and efficiency. So each subsequent generation doubles the internal prefetch buffer, allowing the RAM to deliver more data per clock cycle without actually needing to drastically increase the internal clock speed. Let's go first to DDR. So, when we talk about DDR, it was introduced in around year 2000. It is actually the first generation of these DDRs to transfer data twice per clock cycle on both the rising and the falling edge of the clock signal. Moving on is DDR2, which was actually introduced in year 2003. So the key improvement here is that the bus has improved in terms of its signaling, allowing it allowed the external data bus to run twice as fast as the internal memory cells. The third DDR, or the DDR3, was introduced in year 2007. The key improvement for this DDR is the farther power reduction and faster transfer rates. So this generation popularized low voltage variants. So the prefetch is 8-bit, which doubled from the DDR2. So the next one is DDR4. The DDR4 was introduced in year 2014. So the key improvement here is that there was a major boost increase module density, which is higher capacity per stick. And there was also an introduction of the bank groups for better parallel processing. So if you look at the following images from DDR, DDR2, DDR3, DDR4, it actually changes also the position of the nodes and the number of the pins, which we are going to discuss later more. So, what is the core differences between the mentioned types of DDRs? So, when we look at this key visualization, which is the data rate, the voltage, and also the core differences between the DDR generations. When we look at the two metrics, which is speed and power, each generation represents a massive leap in how much data can actually move. So the data rate measured in mega transfers per second has consistently doubled or more with each generation. The original DDR topped at around 400, while DDR4 starts at 1600, providing significantly more bandwidth to the CPU. Equally important is the voltage. We've gone from 2.5 volts in the first DDR generation to just 1.2 for DDR4. This drop actually dramatically reduces the amount of power consumed and the amount of heat generated, making modern systems much more cooler and more efficient. Finally, if we look at the prefetch buffer, this is the internal chunk of data the RAM chip can read in advance. So this buffer size doubled from DDR to DDR3, which is the core architectural reason that they can deliver more data per external clock cycle. So beyond the speed, there is what we call the architecture and the design. So looking at these images from DDR1, DDR2, DDR3, and DDR4, you can actually see the changes from the number of pins and also the positioning. So the shift from this DDR to DDR2 mark a change in the physical pin count, moving to 240 pins and introduce better bus signaling efficiency. So while the raw numbers tell one story, the physical changes also tells another, mostly about preventing mistakes. When we move from DDR2 to DDR3, the pin count stays the same at 240, but the notch location on the module is shifted electrically. It also brings the 8-bit prefetch and a better low voltage options. The DDR4 introduced the biggest physical change, moving to a 288 pin module with a unique and slightly curved bottom edge. Architecturally, it's smarter, using bank groups to process multiple requests simultaneously, maximizing parallel performance. So, pro tip: RAM generations are not compatible. DDR3 will not fit in a DDR4 slot, and neither will work in a DDR2 slot. So, this is due to both electrical differences and the physical shift in the module notch, which prevents incorrect installation. So, now you know. So let's reiterate our takeaways from DDR1, DDR2, DDR3, and DDR4, which is the non compatibility rule. So if your motherboard specifies DDR4, you can only use DDR4. The physical design, the placement of that notch, and the pin count makes installation of the wrong type impossible. It's like trying to fit a square peg in a round hole. Now, a quick word on latency. Latency is the delay before data is delivered. It is measured in clock cycles, which is a CS latency or CL. While this CL number often goes up with newer generations, the massive increase in the RAM speed more than makes up for it. The result is that the actual time delay, measured in nanoseconds, remains roughly the same or even slightly improves, while the data throughput skyrockets. So, to summarize, the progression from DDR to DDR4 is actually a clear story of higher speed and lower voltage. However, your choice is entirely dictated by your motherboard and CPU. Always consult your motherboard manual to ensure you buy the correct generation. Modern systems use DDR4 or the latest standard DDR5, which we didn't cover today, but continues this trend of efficiency and speed. Thank you for the time and attention of the differentiation of this DDR, and I hope this video helps you understand more about them. So credits to the following resources. Thank you and see you again next time. Bye.